When selecting wire for 115 volts alternating current circuits, several factors must be considered to ensure safety and compliance with electrical codes. These factors include ampacity, voltage drop, insulation type, and environmental conditions. Firstly, let's discuss the selection of wire for a 30 amp circuit with a 115 volts alternating current supply and a distance of 4 feet. Based on the information provided, a 12 American wire gauge wire is recommended. This wire size is appropriate for carrying 30 amps continuously without overheating, while also maintaining an acceptable voltage drop over the specified distance. The National Electrical Code, also known as NEC, provides tables and guidelines for determining the appropriate wire gauge for various current levels and applications. It's crucial to consult these tables, such as NEC Table 310.15b16, which lists the allowable ampacities of insulated conductors rated for not more than 600 volts when selecting wire for any electrical circuit. The ampacity of a wire is the maximum current, in amps, that a conductor can carry continuously under specific conditions of use without exceeding its temperature rating. For 12 American wire gauge copper wire with THHN insulation, the ampacity is typically rated at 30 amps under normal conditions. However, it's essential to consider dating factors for ambient temperature and the number of conductors in a raceway as outlined in NEC section 310.15. If the ambient temperature is higher than 86 degrees Fahrenheit, or if multiple current-carrying conductors are bundled together, the ampacity of the wire must be reduced accordingly to prevent overheating and insulation damage. Secondly, let's talk about the importance of voltage drop in wire selection. Voltage drop refers to the decrease in voltage along the length of a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction, reduce the brightness of lights, and decrease the efficiency of electrical systems. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. To calculate voltage drop, you can use Ohm's law, which states that voltage drop in volts is equal to current in amps multiplied by resistance in ohms. The resistance of a wire depends on its gauge material and length. Larger gauge wires have lower resistance and therefore result in less voltage drop. In the case of the 30 amps, 115 volts alternating current circuit with a distance of 4 feet, using 12 American wire gauge wire will help minimize voltage drop and ensure that the equipment receives an adequate voltage supply. Thirdly, we should discuss insulation type. The insulation on a wire serves to protect the conductor from moisture, chemicals, and abrasion, as well as to prevent electrical shorts and ground faults. The choice of insulation depends on the application and environmental conditions. THHN, which stands for thermoplastic high heat resistant nylon, is a commonly used insulation type for general purpose wiring in dry locations. THHN insulation is rated for temperatures up to 194 degrees Fahrenheit or 90 degrees Celsius and is resistant to oil, gasoline, and chemicals. For the 30 amps, 115 volts alternating current circuit, THHN insulation is a suitable choice, provided that the wiring is installed in a dry location and the ambient temperature does not exceed the insulation's temperature rating. Now, let's shift our focus to the selection of wire for the 4 amp circuit with a 115 volts alternating current supply and a distance of 6 inches. In this case, an 18 American wire gauge wire is sufficient for the low current and short distance. 18 American wire gauge wire has an ampacity of approximately 14 amps, which is more than adequate for carrying 4 amps. Additionally, the short distance of 6 inches minimizes voltage drop, making 18 American wire gauge wire a suitable choice from a voltage drop perspective. Regarding insulation, either THHN or THHW, which stands for thermoplastic high heat and water resistant nylon, can be used for the 4 amp circuit. THHW insulation has the added benefit of being suitable for wet locations, making it a more versatile option if there is a possibility of moisture exposure. Regardless of the insulation type chosen, it's important to ensure that the wire is properly installed and protected from physical damage. In addition to the specific wire recommendations for the 30 amps and 4 amp circuits, there are several additional considerations to keep in mind when selecting wire for any electrical application. 1. Always consult the latest edition of the NEC and local electrical codes for any specific requirements or restrictions. Electrical codes are constantly updated to reflect new technologies and safety standards, so it's essential to stay informed about the latest changes. 2. Use proper wire connectors or terminals to ensure a secure and reliable connection. Loose or corroded connections can cause overheating, voltage drop, and even electrical fires. Use connectors that are rated for the wire gauge and insulation type being used, and follow the manufacturer's instructions for proper installation. 3. Label the wires clearly for easy identification and maintenance. This will help prevent confusion and ensure that the correct wires are used during future repairs or modifications. Use wire markers or labels that are durable and resistant to fading or smudging. 4. Consider the environmental conditions when selecting wire and insulation. If the wiring is exposed to extreme temperatures, moisture, chemicals, or sunlight, choose wire and insulation that are specifically designed to withstand these conditions. For example, if the wiring is installed outdoors, use underground feeder, also known as UF, cable, which is designed for direct burial in the ground. 5. When in doubt, always consult a qualified electrician. Electrical work can be dangerous, and it's important to have the expertise of a licensed professional to ensure that the wiring is installed safely and correctly. An electrician can assess the specific requirements of the application and recommend the appropriate wire and insulation to use. 6. Remember that overcurrent protection devices, such as circuit breakers and fuses, are essential for protecting electrical circuits from overloads and short circuits. Select overcurrent protection devices that are properly rated for the wire gauge and the equipment being powered. For example, a 12 American wire gauge wire is typically protected by a 20 amp circuit breaker. 7. Always de-energize the circuit before working on any electrical wiring. This will help prevent electric shock and ensure your safety. Use a voltage tester to verify that the circuit is de-energized before proceeding with any work. 8. When running wires through walls or ceilings, use appropriate wiring methods such as conduit or cable trays to protect the wires from physical damage and comply with electrical code. Conduit is a rigid or flexible tube that is used to enclose and protect electrical wires. Cable trays are open support systems that are used to support and route cables. 9. Pay attention to the color coding of wires. The NEC specifies a standard color code for electrical wiring, which helps to identify the purpose of each wire. For example, black wires are typically used for hot conductors, white wires are used for neutral conductors, and green wires are used for grounding conductors. 10. Keep wiring runs as short and direct as possible to minimize voltage drop and improve efficiency. Avoid unnecessary bends and loops in the wiring, and use the shortest possible route between the power source and the equipment being powered. By following these guidelines and consulting the NEC and local electrical codes, you can ensure that you select the appropriate wire and insulation for your 115 volts alternating current circuits, promoting safety, reliability, and compliance with electrical standards.